Hello everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 14C. Myself, Vidhi Rahangdale, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and ICICT, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, that is ICICT 2026, London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held previously in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. As the first member of the chair, we have Dr. Hector Rafael Morano Ucono. Dr. Hector Rafael Morano Ucono is an associate professor in the School of Engineering and Sciences at the Monterrey Institute of Technology and Higher Education, Mexico. His academic and research interests include the use of online laboratories in higher engineering education and the application of large language models to finite element analysis. He is actively involved in educational research and has presented his work at international forums such as the International Conference on Education and E-Learning. Welcome to the session, sir. Would you like to address the participants?
Yes, sure. Welcome, everyone. It's a pleasure to be with you. As previously mentioned, this is technical session number 14C. So Dr. Soruya Kumar and I'll be joining you as session chairs. I want to thank you for being here. I'm sure it'll be a very productive session. I also want to thank Vidhi Rajandal for her help as moderator of this session. Thank you very much and welcome everyone. Thank you.
We now welcome Dr. Soroja Kumar Rao as our second member of the chair. Dr. Soroja Kumar Rao is an associate professor in the School of Computer Science and Engineering at VIT AP University, Andhra Pradesh, India. His research interests include artificial intelligence, machine learning, and wireless sensor networks. He actively contributes to teaching and research, collaborates with faculty members, and is engaged in advancing work in cutting edge computing domains at the university. Welcome to Welcome to the session, sir. Would you like to address the participants?
Okay, thank you for this presentation. So, as a session chair, so I'll thank you the organizers team and the team members, other things, and also welcome to all the young researchers, those who are giving the presentation in this STEAM conference. Thank you.
Thank you, sir. We will now move to the presentations. We invite Mohammad Abdul Rida Hussain to present his paper titled A Blockchain and Elliptic Curve Based Scheme for Decentralized Public Key Distribution and Management.
Hello, good afternoon. Good evening for everyone. My name is Mohammed Hussein. I will present the paper entitled A Blockchain and Elliptic Curve Scheme for Decentralized Public Key Distribution and Management. So is my voice clear?
Yes, we can hear you.
Thank you very much, sir. With the increasing demanding of the digital technology, especially with the internet use as a media, sharing media actually, the emergence or the need of security is is a very important issue here. Or we need a security with the communication, sending, transferring, where the security here is may divide it into confidentiality and authentication. So cryptography algorithms present a number of algorithm and cipher techniques as asymmetric, asymmetric. The only issue here is how to manage the keys. And we have, we have here two types of keys or a major perspective, a secret key and a private public key. So the big problem here, after we choose any or certain type of algorithms, cipher algorithms and authentication, we need to manage and distribute these keys. So the centralized system, if we made or manage this distribution through centralized system, we suffer from single point of failure, scalability, limitation, and denial of service. Plus the latency in retrieving or fetching the key from the server. So we proposed in this paper using a blockchain technology to demonstrate the distribution of the keys. To be specified, a public key. If we use infrastructure depending on a symmetric cipher, we need a blockchain to distribute the public key of it. After distribution, or actually after receiving the public key, we can share the secret key through it. So the public key, or the blockchain, is immutable from or immutable storage, because these blocks and transaction within the block is protected through a sequence of hash or hashing, such as a proof of work, stack of work. The second reason we choose blockchain enhanced security, because each transaction stored within the block must be signed through a private key of the owner as a signature. The final or the main purpose of using blockchain is the decentralized distribution, where the blockchain is a sequence of servers contain or synchronize the blocks within the network. So if any problem with one server, doesn't shut down the system or doesn't make a single point of failure. The related work here, as Naeem has proposed a blockchain technology with a cryptography management application. The main drawback here in this paper, sorry, the login page or the exchange key within the login duration are sent in plain text. For Jawad is developed a healthcare system based blockchain to manage the keys, but suffer from the same drawbacks or disadvantage, which is the keys are transferred to the blockchain in the plain text. So any man-in-the-middle attack can hold it, can know, or can receive the plain text or the public key. For Panda, key management techniques used within the IoT environment, actually he used a different level of hierarchy. The problem here, the same or the main problem is transferring the key within the hierarchy, within the levels of hierarchy, even in plain text without any encryption. For Ma, author is actually he has two proposals in VANET and in IoT. Both basically are the same, but the problem here is updating, how to update the key and how to manage the key within the blockchain, and even its send or transfer in the plain text. Finally, either here is present a blockchain to contain or to manage a private key techniques. Here the idea is okay, but the private key must be known for only the user, not in public. So even so is transferred in a plain text. So in our proposal, we suggested three phases as a client registration, key storage, and secure changing or exchanging, sorry. Client registration here is how each client has a private public key. So first, he must register the public key in the blockchain with a unique ID. The ECC here is to generate a private key or the secret key to exchange between the client and the blockchain server. Key storage here, after the blockchain receive the encrypted public key from the client, he decrypt it, decipher it, and make or ensure the ID of the user and store this public key with the ID within the block as a transaction with digital signature using the public key of the private key of the blockchain server as an authentication phase. Finally, the secure exchange is any client wants to communicate with other clients. First, he send a request to the blockchain with the ID of the client, the receiver actually, and the need of the public key. This exchange between the client and the blockchain, as we said before, is ECC protected. So the blockchain will retrieve the public key of the destination client and send it to the first source client in a secure manner. The client will randomly generate a secret key, symmetric key, and send it to the receiver or the node B, sorry. It will generate or it will decipher the public key, the symmetric key, and transfer the data between the two clients. As a security analysis, our proposal is prevented from man-in-the-middle attack because all the transactions, all all the messages between the client and client A and client B and between a client and blockchain are protected through ECC diffie-Hellman encryption. Replay attack here, the proposal based on used the timestamp in each message to deny or to prevent replay attack to retransmit the same message. Blockchain server impersonation, the attacker cannot be impersonate as a blockchain server or fake server because the ECC initial parameters, he doesn't have it. Privilege insider threat, here the same reason actually, the ECC parameter, the attacker cannot be retrieved or handled, possessed, to regenerate or to impersonate as insider attack. As a simulation or as a performance for the key distribution with a comparison with the main papers as Pada, Naim, and Shakur, we can see our proposal used symmetric encryption plus public key operation, while Pada used hash, public key, and n number of hash because you use a tree of hashing. As we said before, is levels or number of levels, layers in the system. While Naim use symmetric key plus hash function, that's why it's doesn't take a lot of times. While Shakur use public key decryption, hash function, and ECC, that's why it's has more time than others. While our proposal, let's take a reasonable time, construct with the robust security protocol. This is the main parameter for the protocol for the communication between the server and the client. For the conclusion, through blockchain, we can manage decentralized security or key management, secure key management. We prove the security of our proposal through SVO logic and through performance. So blockchain with ECC, as we suggested, it's a robust key management suitable for various of networks such as IoT environment, cloud environment, VANET environment, healthcare environment. It depends on the application. Thank you for listening.
I request the chair to ask questions.
Yes, sure. Thank you for your presentation. So I just have one question. How could this scheme be evaluated in real-world environment with thousands of users and multiple blockchain nodes?
Yeah, thank you, sir. Actually, it's depend on the blockchain or on the environment, real world environment. If we use it through an IoT, we suggest as a private blockchain servers to manageable to be as secure as possible. But for the VANET, it will be vast. Actually, we need so much test for it.
Okay, thank you.
Thank you.
Okay, my one question based on your blockchain service decentralized based on that. So how can you detect that MITM attack?
Sorry?
You are
Man in the
using
middle
the
attack?
man in middle attack. Yeah,
Yes.
man in the middle attack. How can you detect your system? How can you detect that MITM attack?
Yeah, sorry. Our system doesn't detect any attack. It actually prevents the attack from accessing it. So if the man-in-the-middle attack generates or started with the ARP spoofing and enter the network, he cannot read any message within the transferring between any nodes because it's ciphered or it's encrypted within or using ECC.
Okay, how it is solved the ARP poisoning case?
Sorry?
How it is solved for your solution ARP poisoning case in case of the attack?
Yeah, it's our proposal doesn't solve the ARP poisoning attack. If the attack happened, the man-in-the-middle attack be within the network but cannot be read any message, not preventing ARP poisoning.
Okay, thank you.
Thank you, sir.
May
The
I
next
question,
presentation.
please? May I
Yeah,
question?
please.
Yes, sir. Yes, yes.
Thank you for your presentation, Dr. Mohammed.
Thank you very much.
I have a question about how does your system handle key revocation if a private key is compromised?
Our private key is compromised. You mean the
Yes,
client?
your system handle key revocation if a private key is compromised. Yeah.
Yeah, it must be regenerated.
Regenerated.
Yeah, regenerated. We didn't actually make this situation in the paper.
Yeah, because during your presentation, I was thought about how does your system like this handling key. Thank you very much.
No, thank you very much. We'll make it as a future work.
We will now welcome the next presenter.
Thank you.
Thank you. We now invite Sindhuja Penchala to present her paper titled Bridging the Gap Toward Cognitive Autonomy in Artificial Intelligence.
Sure. Just a minute, I'm sharing my screen. Are you able to see my screen?
Yes, we
Yes,
can
sir.
see your screen.
Oh, yeah. Thank you so much. Just a minute. So, good morning and good evening, everyone. Firstly, I welcome to the 11th International Congress on Information and Communication Technologies held in the London. Today, I'm going to present a paper titled Bridging the Gap Towards Cognitive Autonomy in Artificial Intelligence. So, here are the other list: Dr. Nurbak Amirigullas, myself, Sindhuja, and Sharam Rahimi. Myself, Sindhuja Penchala. I'm a grad student from University of Alabama, Tuscaloosa, from United States of America. So today I'm going to discuss the contents, what is the main motivation behind the paper, the objectives and AI limitations, what are the future directions that can be applied, and the conclusion. So coming to the motivation of this. So what is the main motivations to have the survey on this paper? Currently, if you see like past decade, AI has taken over the world. So wherever we see, there is AI. All the industries, all the sectors are going through the AI, so in order to automate their systems. So today AI can understand the language, it can recognize images, and it also make decisions, and it also can solve the complex problems. So it can do everything, almost everything, uh, to solve complex problems. And it also uses some deep learning and transformer models, and also it can uh, automate all the complex tasks to make it easily. But there exist few problems. Like if you think like AI is not that intelligent, it means like it is good, but there are also some constraints. Like it cannot think independently. So whatever we give that, it gives the solution it knows, and it cannot adapt to its own changes. It cannot monitor its mistakes, or it cannot correct itself. So despite of being advantageous, they're also having some drawbacks that we need to overcome. So that's where we are saying like we need something, a backup plan or something, in order to overcome all these things. That's what cognitive autonomy is here. So cognitive autonomy is nothing but where AI can think. So it can think, it can adapt, it can regulate itself like humans. So we need to train a few things in order to make the AI think. So coming to the research questions, the first research question we have here is what essential components of the cognition are missing from the current AI systems to achieve this cognitive autonomy. So I'm going to discuss the essential components and why do modern AI systems lack robust autonomy, the adaptability and self-regulation, and what components are required to enable this cognitive autonomy in AI systems. And why do AI systems succeed in narrow tasks, but they fail in some real world environment? And how can AI systems evolve towards the cognitive autonomy using neurocognitive principles? So these are all the main queries that we are going to discuss. Coming to the introduction, as we have discussed, like AI has rapidly advancing using all the deep learning and transformer architectures, and these modern AI systems can achieve all these like understanding languages, they can do the vision part, everything. But there is a need to for the cognitive AI for the AI to self-direct and adapt to the changes like humans. So in order, uh, let me explain the AI limitations. So despite having the main advantages, there are also having some AI limitations. First thing is it operates in the reactive mode. It means like today AI works with the reactive mode, like it reacts to the input. If you give any some uh, prompt or something, it gives the responses back, and it does not understand what its state is, like what its internal state is, and also it reflects on its own decisions, or it cannot learn continuously. If you think, if you train a model, it stops, it learns till the training part. So after the deployment, it cannot learn what is going to be, right? So learning is stopped in the middle. So if there is an environment change, AI will struggle to learn the new things. So these are all some limitations with current AI. In order to overcome these, we have come with an objectives. First, like we need to identify what are the key cognitive capacities that are missing in the modern AI system, and we are going to analyze the structural limitations that preventing the cognitive autonomy, and we are also going to connect the insights from the AI research and the cognitive science, and I'm going to provide the conceptual framework of cognitive autonomy. So what is the architecture of the cognitive autonomy in the AI, and the I'm going to highlight the future directions towards the autonomous and adaptive AI systems. So firstly, I'm going to discuss the seven core deficiencies what AI is lacking right now. First one is absence of intrinsic self-monitoring. It means AI cannot check if it's wrong or not. So it cannot evaluate, self-monitor itself. And second one is lack of metacognitive awareness. It means like AI does not know if it's intelligent. It means it does not know what it knows, what it does not know. So that is one of the thing. It cannot recognize its knowledge gap. So what its knowledge is up to. And third one is fixed and non-adaptive learning mechanism. So after training, it stops learning. As we told, like there is a training and testing part. After training, it stops the learning part. It cannot adapt with retraining. And coming to the fourth one, inability to restructure goals. So it cannot change its goals. It only follows the given instructions. So this is also one of the drawback. And lack of representational maintenance. So if we change some internal knowledge, so if the internal knowledge becomes inconsistent, so AI cannot fix it. So if it's consistent, then it can be like it can know what it is. So if there is any knowledge inconsistency, that AI lacks fixing it. And coming to the next one, insufficient embodied feedback. So AI does not learn through the real world interactions like humans. And the last one is the absence of intrinsic agency. So AI has no curiosity. It means like it does not explore on its own. So it only acts what we prompt like that. So these are the main code deficiencies that the AI is lacking. So what is missing in today's era. This is almost the similar. Here, these seven deficiencies are divided into three layers. First one is internal evaluation. Under the internal evaluation, self-monitoring and metacognitive awareness comes under this internal evaluation. And next, adaptive learning rules, goal restructuring, representation of maintenance. All these come under the adaptive control, and the embodied feedback and intrinsic agencies come under the embodied autonomy. So, in order to uh, make these better, so if we make them with the cognitive autonomy, add the cognitive autonomy, then it can be reduced the hallucination. So if you give some prompt to the LLM, you can get a response. So if it doesn't know what the correct answer is, it hallucinates. So it hallucinates and gives the answer what it knows. So that is one of the drawbacks. So we can reduce the hallucination, and we can also reduce the overconfidence. And after the cognitive learning, we can have the lifelong adaptation and the knowledge updating. So we can update the knowledge, and also next the self-directed explorative thinking. So this is all about the today's AI lacking, and what outcomes can be seen after this cognitive autonomy. So coming to the implications, currently we have like these are the high level implications that are missing of missing cognitive capacities in modern AI. So the reliability and safety. So if we have the reliability and safety, like because of these limitations, AI can be overconfident and unsafe, and AI cannot generalize well. If you think there is a task, like for example, there's a classification task. If you have trained a model using the images, so images can be a cat, dog, or something. So these images are taken in the daylight. If you think if these images are taken in the daylight, so model can only generalize those images of daylight. If you give the cat images of occluded, like occluded image of a cat, like if it's a poor lighting of dark image of a cat, it cannot generalize well. So this is one of the drawback. If you change the environment, if you change the lighting, it cannot generalize. So this is one of the limitations of current AI, like poor transfer learning, inability to adapt online, and generalization is also lacking, and autonomous cognitive behavior. And because of this, the resulting limitations are like there is no inability to restructure the goals, and there's an absence of autonomous reasoning and self-directed exploration. So these are all the current implications of the modern AI. In order to fix all these, we are coming with the cognitive architecture. So this is the main overview diagram of the cognitive autonomy. If you see here, there are seven layers. First, coming to the perception unit, perception and to action. So this is a closed loop. If you see, this is a closed loop from the perception to action. The perception unit, the attention, memory, learning, reasoning, and adaptation. Once, if you give the input modalities, the perception unit, it goes into the attention model. So first perception is nothing but the like we are building the meaningful representation from sensory input. And second, after giving the input, it will select only the relevant information. So it will remove all the distractions or irrelevant information, and also it only selects the relevant informations from the given input. Coming to the memory. So memory is nothing but this layer stores the information, the required information that is used for reasoning and the learning. And next, learning module. Here in this layer, it updates the knowledge. So if you think there is only data up to last year, it updates the knowledge of the current year also. So in this layer, the updating is done based on the experience of the feedback. And next, the reasoning engine. Here we are going to apply the logics to interpret the situations and decision making and all. And adaptation layer. This layer is used to adjust the strategies. So in order to this adjust the strategies in response to change the conditions. And coming to the action unit, finally it makes, by taking all this, it makes the decision. So it makes the decisions and generate the output for improvement. So if there are any errors in the action unit, it gives the feedback. It
I'm
goes to the
sorry to
feedback layer.
interrupt. This is a gentle reminder that
Yeah, okay.
10 minutes are up from the 12-minute presentation. We kindly
Okay. I'm almost done. Yeah, it goes to the perception unit. So this is a closed loop. So after the errors, it gives the uh, correct input. This is the cognitive architecture we have implemented. And coming to the future direction, in future, like we can develop the self-learning AI systems, and we have used the closed loop autonomy, and we can enable the continuous learning and support the intrinsic motivation. And we are going to integrate the cognitive mechanism for autonomous intelligence. So this is the conclusion. Right now, modern AI is lacking cognitive autonomy, and it also missing the self-monitoring, adaptive learning. And in order to close all these gaps, we are coming with the cognitive autonomy in the future. So this work is supported from the Brains Lab from University of Computer Science, Department of Computer Science, Alabama, and from the Brains Laboratory. These are the references. So any queries?
Okay, my question based on your cognitive architectures.
Hmm. Hmm.
Inside your architecture, there are two layers called as the learning module and the reasoning engine. So my question is based on this learning module and the reasoning engine, how it executes the decisions and generate the feedback.
So first, as we
Learning module
told
and
this.
reasoning engine. Yes. Yeah. Please
Okay,
proceed.
okay. So once, for example, if you take the LLMs, like it has
Yeah.
memory of only up to some point, right? So in the learning module, we are going to update resources from different resources. Like if you think it's not only from website, we are also including the resources of different knowledge bases. So in the learning module, we are going to update the knowledges from different sources. And coming to the reasoning, here the reasoning is going to happen. It means like we are going to apply some logical things to make the decision. So for me, let's give me an example. Um, so if you give some a prompt to right now the current AI, it will answer. It will answer, but it will answer what it knows, but it doesn't go beyond. It cannot make decisions. So if we update the learning module with current knowledge bases, the current knowledge bases, so it will make decisions accordingly. So if you think, um, can you, if you give some negative questions like, can you self modify the code? In the current AI, it is giving like, yes, actually, we cannot self-modify the code, but it gives the modifications of the code, this. Actually, it is a risky part. So that needs to be ignored. But what if we update with the uh, better knowledge things? It will say, this is the risky, you should not do this thing. You need to come up with alternative solution. So here we are going to update. Here it's going to make decision.
Okay.
Is this clear?
Thank you.
Okay. Thanks.
Thank you, ma'am, for your presentation. We don't have more
Okay.
time for questions,
Okay.
so let's move for the next presentation.
Thank you. Thank you so much.
Thank you.
Thank you. We will now move on to the next presentation. We invite Geraldo P. Rocha, Fellow, to present his paper titled From Camera to Alert: Direct and Multi-Class Detection of Driver Distractions at the Wheel.
Hello, just a moment to share my screen. You see my screen?
Yes, we can see your screen.
Okay. And hi, folks. My name is Geraldo, and today I will present your works intituled From Camera to Alert, Direct and Multi-Class Detection of Drive Distraction at the Wheel. This work is a partnership with the WNB and WESB and was developed by your undergraduate student, Carlos Gil. On overview, this work proposes a mobile computer vision system capable of detection drive distraction in real time using only a smartphone. So, in summary, I will present the problem context, the related works, and the research gap. In, in conclusion, so in traffic safety remains a global challenge. Every year, about 1.19 million people die in traffic accidents, and studies show that more than 96% of collisions are caused by human factors. Therefore, improving drive behavior monitoring is essential to reduce accidents. So, I will talk the distraction types. Drive performance can be affected by three types of distraction. The first, visual, manual, cognitive. Distraction visual when the drive looks away from the road. The manual, when hands leave the steering wheel, is cognitive when attention is diverted. So, many real-world situations combine all three simultaneously. So I talk about the smartphone. The smartphone is the most critical distraction because it's combining distraction visual, manual, and cognitive. In Brazil, lack of the attention account for about 43.7% of fatal accidents on federal highway. This, this motivates automatic monitoring solution capable of detection risky behavior. So current road safety strategy really mainly on legislation and vehicle embedment system. Legislation only acts after the violation occurs. Advanced drive extension system exist but are limited to expertise vehicle and may fail under devices condition. Therefore, we need accessibility and real-time monitoring solutions. In context, in IA, artificial intelligence especially computer vision and deep learning, wholly automatic understanding of driver behavior, convolutional neural network and object detection models can identify risk actions directly from camera images. This enables scalable and low-cost monitoring using common devices such as an smartphone. So I will about the related work. There are several approaches have been proposed in the literature. However, most solutions detect only one aspect of the problem. Some only classify images without localization, while the others localize actions but do not support multiple classes, and many are not designed for real-time mobile execution. Your proposal, intitulado Distract, combine all these characteristics simultaneously: direct detection, localization, multi-class recognition, single model architecture, generalization in real-time capability. For this, the model or objectives. The objective of this work is to develop an evaluation, the solution to distract, a mobile application capability of detection of drive distraction in real time and alerting the driver to promote safer driving. So one overview of this solution. Distract is one smartphone based in system that capture in video from the front camera, process o frame locally, it detects a distraction events. When a distraction is detected, the system alerts the driver and store an event. While process occur directly on devices without internet connection. So we dataset users will build a hybrid dataset using three sources. The first, state farm distraction drive dataset. Second, drive and action dataset. E3, and real world collect data. We focus in four important behaviors in the roaders classes, né? Phone using, radio operation, drink, and researching behind. Né? The final dataset contains more than 4,000 images. So there is a step in pre-processing. We extract frames from videos, filter low quality samples, and manually annotated in bounding box. We also included negative images to reduce false positives. Finally, we applied data augmentation to improve generally on the different light and camera position. Its model developed, we used YOLO architecture. Instead of classes images, we formulate the problem as a single regression tasks. Then that simultaneously prediction bounding box in class probability. This allowed direct detection in location with low computing cost in suite for edge devices. So these interfaces, the applications display detect on screen improved visual and audio alerts to the conductor, the driver. So about the performance evaluation. Performance evaluation in stage. Evaluation of the model is prediction effects and performance evaluation on mobile devices. We evaluations both prediction accuracies and operations visibility on mobile devices. So for this, we used precision, recall, MEP metrics. This table show mobile device specifics, ASUS model, os parâmetros used, né, for model, and performance evaluation of distracts on box loss, class loss, and loss metrics, né? These graphics show the trend curves show stably converge on the overfit, né, in 3 graphics. Seguida, the model archives high detection performance, precision closing in 0.97 percentile, recall nearing 0.95 in this demonstration, reliably recognition and localization in distract behavior. So conclusion, distract is socially integrated YOLO with a mobile application for real-time detection of drive distraction. The system archive high detection accuracy and operation efficiency how low in the devices is therefore its presence on accessibility solution for improving road safety. And finally, future works includes personalities for drive and integration with intelligence transporting systems. Thank you. And every some questions sent to my mail.
May I question, please,
Okay,
Doctor?
I have one. Yeah. Okay, I
Okay.
have one question. You are using the LOV11 model. So can you compare with the other models so that your model accuracy and your model recall and model your precision is good? Are you compare with other models?
Yes, in future works, and there is one student in working this. Okay.
Dr. Geraldo?
Hello, listening?
Yes, please.
Yeah.
How does your model
Actually,
perform under different lighting conditions? Because I was working near for your paper before. So, yeah, camera angles or occlusions.
So,
System
and
optimized for real time?
yes. And evaluation in real time in smartphone. In the
Yeah.
so the camera is front of user the driver. In I need to evaluation different angles.
How do you minimize false alerts to avoid distracting the driver further?
This is the future works
This is a future works.
to
Okay.
doing.
Okay. Thank you. Thank you for your presentation.
Okay.
We will now move to the next presentation. We welcome Muthir Kwasime to present his paper titled Robust and Sustainable Vision Transformer in Retinal Optical Coherence Tomography Diseases Classification.
Hi everyone, do you hear my voice?
Yes, we can hear
Yes,
you.
sir.
Okay, great. I'm sharing my screen now. Is it visible to all?
Yes, we can see your screen.
Okay, great. Just 1 minute, please. I'm trying to share the entire screen, but I don't found it as an option. Is it clear now?
We can see the application, not the presentation. The first
Oh,
slide is down.
first slide is now down. Yeah, I know. Tried it. Okay. Okay, this is the agenda for my presentation. First, I have to introduce myself. I'm Munder Gesaime, master student at Georgia University of Science and Technology in that science department. My research work and paper work is robust and sustainable vision transformer in retinal OCT disease classification. Retinal diseases are one of the leading causes of blindness. Millions of people are losing their vision due retinal disease conditions. The doctors were facing challenges such as overlapping in diagnose, manual interpretation is slow, high patient volume leads to variability in diagnose. So the AI helped the doctors to handle these challenges, but actually, the AI models now are facing a new kind of challenge, such as the security challenge, adversarial attacks, which could add small perturbations and slight change on image pixels to fool the model, and sustainability challenges, such as the hospitals may don't have servers with huge capabilities to deploy or handle complex models. So the computational costs, slow inference, high energy consumption, all of that are a new challenge. The retinal OCT demonstrated that the vision transformer is actually outperformed the CNN in classification, while the CNNs are more efficient than vision transformers. So we have this motivated us to enhance the efficiency of vision transformers. Limited studies focused on VIT's robustness against attacks. They focused more on CNNs. Robustness of many workers actually focused on improvement in VIT efficiency improvements by proposing small or lightweight architectures like a mobile VIT, but the adversarial robustness of mobile VIT is still unknown. We need to investigate it. Prior work actually did not address softmax saturation and normalization challenges in adversarial work. The normalization challenge actually it is the conflict between the pixel space and the ImageNet normalization space, because the ImageNet converts the pixel space to ImageNet pixels space. This will harm the adversarial training and evaluation, because it will change the epsilon value, which is an improper normalization. The softmax saturation challenge, this happened because the VIT model split the image into patches, and when the classification decision rely on just only one patch, this will lead to have an overconfident model, and this model may be more sensitive against adversarial attacks, because any slight change on this patch will lead to overconfident model with making wrong predictions. So our research objective is to build a strong model, extending number of classes to 8, because we found that it is a limitation in prior work. Enhance the VIT model robustness against VGSM and BGD attacks. Enhance model calibration to mitigate softmax saturation. improve efficiency by model compression technique. We proposed a pruning technique to compress to reduce model size, build a lightweight model that is more robust than mobile VIT, and also we will investigate mobile VIT robustness against attacks. Actually, enhance the adversarial training by mitigating or solving the normalization issue. Literature work papers, the first study was limited to CNNs. They focused more on CNNs and they did not do any adversarial work. They focused on efficiency enhancement. Second study also was limited to binary classification and it was also focused only on CNNs. The third one actually it was limited for binary classification and did not handle the softmax saturation and the normalization issue. The study number 4 actually they proposed mobile VIT as a lightweight architecture, but they did not investigate their robustness against attacks. And the last study actually proposed two models which caused a heavy deployment. One model as a detector to detect attack, and then pass only clean samples to the classifier as the second model as a classifier. Actually, designing our model included many phases, starting from phase 1, which is the data collection phase. We utilized the OCTC8 dataset, which is available on Kaggle, including 24,000 images across 8 classes, and it is a balanced data set. Here we increase the number of classes to reach 8 class, 7 diseases, with only just one for normal situation. This will help doctors to diagnose more, to be enabled to diagnose more diseases. The proposed model, it is the benchmark for VIT model. It is the B60. Okay, it is the standard VIT model with multi-hit self-attention to capture, to divide the image into patches and then measure the attention score for each patch and get the relationship between patches. After that, the token is gonna be sent to or passed to MLP fully connected layer with a softmax function to make classification probabilities. The model architecture actually included 12 blocks and 12 attention heads. We proposed a softmax anti-saturation techniques, which is the temperature scaling, extra boost attention layer, gradient clipping, and label smoothing. And actually, we proposed to wrap the normalization into the model instead of doing normalization in the preprocessing pipeline. This will solve the issue of normalization. The clean training pipeline, we utilized the holdout validation, which is a 70% as a training set, 15% as a validation, and 50% as testing set. We applied resizing and augmentations. Early stopping was triggered to stop training after 3 rounds without any improvements. And hyperparameter tuning also it was utilized to select the most optimal value for learning rate and weight decay. The pruning phase, actually here we pruned the model. The model included 12 blocks, so we reduced the number of blocks to 6 based on importance. We just only kept the most important blocks based on the gradient, the average of absolute gradient value inside the model parameters. The adversarial, after pruning the model, the phase followed by the adversarial training, the model fine-tuned on a clean samples, and after that it is trained on a mix between BGD samples and clean samples. It is the standard adversarial training pipeline. It is a benchmark in research work. Here we can find that the wrapping model wrapping the normalization inside the model will lead that the attacks gonna be added before the normalization, so the conflict actually it is handled. We don't have any problem after that. We utilize a set of parameters for training our model. It is adversarial work parameters as a benchmark for ImageNet pre-trained models like a VIT model, and we selected mobile VIT as a baseline from the prior work to investigate their robustness against attacks and also to compare our model robustness with mobile VIT. We evaluated our work based on metrics such as the performance metrics such as the accuracy, efficiency metrics such as the flops, inference time, inference memory, robustness metrics such as the attack success rates. And actually, the results demonstrated that the broad model achieved a significant efficiency enhancement. The flops dropped, inference time, the memory usage, model size, CO2 emissions. All of these metrics are dropped by approximately 15%. Okay, while the accuracy just only dropped within 1%, which is a slight drop. Not that big significant. The mobile VIT actually demonstrated that it is a very good model against clean samples, but it's may not robust enough against adversarial work, especially against BGD attack. The proposed model demonstrated that after applying the adversarial training, it achieved a great performance against the clean samples and against the adversarial attacks, and average softmax probability. It is a metric to show that to check if the softmax saturated or not. Based on the calibration enhancement, we can find that we mitigate the softmax saturation issue. This figure demonstrates the drop in flops, which is a significant efficiency enhancement. And this figure demonstrates the robustness comparison between the proposed model and the mobile VIT. We can find the proposed model outperformed the mobile VIT in robustness. Here we can find the confidence levels before the adversarial applying the proposed adversarial training pipeline. We can find that the alliance or the alignment between the accuracy and confidence level enhanced after applying the proposed adversarial training. So the softmax is much mitigated, and we can consume that this model is well calibrated. Our future work is gonna be extend this work by more architectures and by more attacks. Any question?
Thank you for your presentation. Are there any questions for the audience? No? Okay, I have a brief one.
Please.
Yes? Do you have a question?
Yes.
Please, go ahead.
Okay, thank you very much about your presentation, Mr. Mulder. When compressing the VIT to improve efficiency, how did you ensure that robustness against FGSM and PGD attacks was not degraded?
While compressing? Yes.
When compressing the VIT.
Yes, actually, we compressed the VIT based on importance. So we selected the most important blocks or layers. Okay, so it should be that the model will select just only the most robust blocks. So the compression or the reduction in model size will not impact the clean performance or the robustness against attacks. But also, my objective was to enhance the efficiency and the security or the robustness jointly, both, not just only one.
At the same time.
Yes, exactly. Yes. So this is my objective, and for that reason, I reduced the model size, and at the same time, I proposed a defense mechanism to enhance model robustness against attacks.
Thank you very much.
Thank you.
Thank you.
Dr.
We can move.
Saroja.
Saroja.
Yes. Yes, sir.
Yeah. I have one question regarding that. How your model is pruning and yearly stopping problem.
How the model, sorry, can you please?
Yeah. How your model is pruning and solve the yearly stopping.
Okay, the early stopping. Okay, actually,
Yeah.
we utilize the early stopping to stop improve training after 3 epochs without any improvements. Okay, in the cleaning in the clean training phase, and actually the early stopping also it was used in the adversarial training pipeline to stop training after 2 epochs without any improvement.
Okay. Thank you.
Thank you.
Thank you. We will be moving to the next presentation. We would now like to invite Firaz Shaukat Hamid to present his paper titled TC CADNet, a temporal context-aware deep learning framework for real-time colon cancer detection from colonoscopy videos.
My screen, is it visible now? Hello?
Yes,
Yes,
sir,
we
we
can
can
see
see
it.
your screen.
Okay. Good evening. First, I would like to extend my sensor thanks to the organizers of ICICT 2026 for their excellent organization of this remarkable international conference. It's a great honor to present my work at such a respected global forum. Today, I will present TC-CADNet, a temporal context-aware deep learning framework for real-time colon cancer detection from colonoscopy videos. The main idea is integrating spatial and temporal modeling to improve segmentation stability while maintaining real-time performance. The motivation behind our work, colorectal cancer, is one of the leading causes of cancer-related death worldwide. Early detection is very important to reduce mortality. However, during colonoscopy procedures, the polyp miss rate can exceed 20%. This means some polyps are not detected, which may later develop into cancer. Most existing CNN-based models analyze each frame independently. They don't consider the relationship between consecutive frames in a video because of this. Predictions can be unstable or inconsistent. Therefore, there is a need for stable and real-time segmentation system that can maintain temporal consistency and assist doctors during live procedures. Although colonoscopy is the gold standard, studies show that miss rates can exceed 20%. Traditional CNN-based system process each frame independently, ignoring temporal continuity. This leads to unstable predictions and flickering masks. Our contribution is a hybrid architecture combining spatial CNN features with temporal transformer modeling. We also introduce a temporal consistency loss that reduce flickering. The system runs at 28 FPS, making it suitable for clinical deployment. This slide summarizes the main novel contribution of our work. Hybrid CNN plus transformer. First, we propose a hybrid CNN and transformer architecture. The CNN backbone extracts detailed spatial features such as texture, edge, and morphology. On top of that, the temporal transformer model relationships between consecutive frames. The combination allows the network to capture both spatial precision and temporal dependencies, which is crucial in colonoscopy videos where motion and occlusion frequently occur. Number two, temporal consistency loss. Second, we introduce a temporal consistency loss instead of treating each frame independently. This loss enforces prediction stability across adjacent frames. As a result, the model reduces flickering effects and false positives caused by motion blur or rapid camera movement, producing smoother and more reliable segmentation results. Cycle GAN augmentation. Third, we apply cycle GAN-based data augmentation since medical datasets are often limited and vary across devices and hospitals. We use cycle GAN to generate realistic style variations. This improves generalization and robustness to different lighting conditions and imaging domains. Real-time performance, 28 FPS. Importantly, our model runs at 28 frames per second. This meets real-time clinical requirements, meaning it can assist doctors during live colonoscopy procedures without delay. High accuracy, dice 0.921. Finally, the model achieves a dice score of 92%, demonstrating high segmentation accuracy. This indicates a strong overlap between predicted masks and ground truth annotation, confirming both precision and reliability. Overall, our contribution lies in combining spatial learning, temporal modeling, stability enforcement, and real-time efficiency into a unified framework suitable for practical clinical deployment. This slide presents the overall architecture of TC-CADNet for real-time polyp segmentation in colonoscopy videos. The pipelines begins with sequential video frames, which are first processed by a CNN encoder to extract rich spatial features such as texture and structural patterns. Instead of analyzing each frame independently, the extracted features are passed into a temporal transformer encoder. This module models relationships between consecutive frames using learnable positional embeddings, allowing the network to maintain temporal consistency and reduce false positives caused by motion blur or rapid camera movement. The temporally enhanced features are then projected and fused through a feature fusion model. Finally, a segmentation decoder with upsampling and skip connections restores spatial resolution and generates a pixel-wise segmentation mask. The final output is a real-time segmentation mask highlighting suspicious regions enabling stable, accurate, and clinically reliable polyp detection during leave procedure. The CNN extracts special features, the transformer model, interframe dependencies, then the fusion model combines them before decoding the segmentation mask, as we mentioned before. Dataset and training. We evaluated on two public datasets and enhanced robustness using synthetic augmentation via cycle GAN. It's a cycle consistent generative adversarial network. The datasets and training setup used in our study, we trained our model using two publicly available polyp segmentation datasets. KV-ASER segmentation with 1000 annotation images and CVC clinic DB with 612 images. To further improve generalization, we generated 2000 additional synthetic frames using data augmentation techniques. For training, we use the Adam optimizer and trained the model for 100 epochs to ensure stable convergence and good performance. We note here smoother boundaries and reduce false positive compared to baseline models. Here we present the qualitative comparisons of segmentation results. On the left, we have the original input frame from the colonoscopy video. Next to it is the ground truth mask, which represents the expert annotated polyp region. Then we compare the prediction from UNIT with the prediction from our proposed TC cabinet. As we can see, the UNIT prediction slightly, I'm sorry. UNIT prediction slightly deviate from the ground truth in terms of shape and boundary accuracy. In contrast, TC cabinet produce a segmentation mask that is more consistent and closer to the ground truth. This demonstrates that incorporating temporal modeling improves boundary precision and overall segmentation quality. Overall, our method provides more accurate and stable segmentation results compared to the baseline model. The improvement is mainly due to temporal context modeling, which helps maintain structural consistency and reduces prediction noise across frames. Compared to baseline model, TC cabinet produces smoother boundaries and significantly reduces false positives, notes the improved stability across challenging frames. Quantitative results. The quantitative performance of our proposed TC cabinet, as we show here, dice and precisions F1 score. So our proposed TC cabinet, our model achieved a dice score of 0.921, which indicates a high overlap between the predicted segmentation and the ground truth mask. We also obtain a precision of 0.917, meaning the model produces very few false positive detections. F1 score is 0.91A, showing a strong balance between precision and recall. In addition to accuracy, the model runs at 28 frames per second, which satisfies real-time clinical requirements. These results demonstrate that TC-CADNet achieves both high segmentation accuracy and real-time performance, making it suitable for practical deployment during colonoscopy procedures. The high DICE and F1 score confirm segmentation reliability, while the real-time speed ensures that the system can assist physicians without introducing latency. As shown, a quantitative comparison between TC-CADNet and several widely used segmentation architectures, including QNet, ResNet-based models, and HardNet. As shown in the table, UNet achieves a DICE score of 0.873 with 18 FPS, while ResNet and HardNet provide gradual improvements in both segmentation accuracy and inference speed. However, our proposed TC-CADNet outperforms all baseline models, achieving a DICE score of 0.921 and precision 0.917. This represents a substantial improvement in segmentation overlap and reduction of false positives. In addition to accuracy gains, TC-CADNet achieve, as we mentioned, 28 frames per second, exceeding the real-time threshold required for live colonoscopy procedures. The performance improvement can be attributed to three main factors: the integration of temporal modeling through the transformer encoder, the temporal consistency loss that stabilizes predictions across frames, and enhanced data
I'm sorry
diversity
to
through
interrupt, sir.
augmentation.
The 13 minutes of the presentation are over. We kindly ask you to wrap up this session.
Okay. Overall, the results demonstrate that TC-CADNet achieves superior balance between accuracy and computational efficiency compared to the conventional frame-wise CNN architecture. The ROC receiver operating characteristic curve shows superior discriminative capability across threshold. ROC curve plus precision recall curve comparison. The ROC and precision recall curve analysis of TC-CADNet compared with the baseline model, including UNet, ResNet, CNN, and HardNet CPS. The ROC curve shown in the left illustrates the trade-off between the true positive rate and the false positive rate across different decision thresholds. So this dominance across the thresholds confirms that the proposed method provides stronger class separability and robustness under varying decision boundaries. On the right, the precision recall curve is presented. This metric particularly important for medical image segmentation tasks where a class imbalance is common. Overall, the fact that TC-CADNet dominates both the ROC and precision recall curve across operating points demonstrates strong discriminative power, robustness to threshold selection, and improved balance between sensitivity and precision. In summary, the curve dominance confirms that TC-CADNet achieves a superior generalization and stable performance compared to conventional frame-wise CNN architecture, particularly under clinically realistic threshold variations. Temporal consistency analysis. This slide presents the temporal consistency evaluation of the proposed TC-CADNet model. So in the left graph shows temporal deviation across sequential frames for multiple models, include DANET and DeepLab V3 and CADNet and our proposed TC-CADNet, as observed, TC-CADNet consistency maintained the lowest deviation across frames. And in the right figure summarizes the average temporal deviation for different methods. We observe a clear reduction when moving from unit, ResNet, CNN, and 430 TC-CADNet. In summary, the substantial reduction in temporal deviation validates that incorporating transformer-based temporal modeling significantly enhances prediction consistency, making TC-CADNet more suitable for real-time clinical deployment. In conclusion, this work demonstrates that integrating spatial and temporal modeling significantly enhances video-based polyp segmentation performance by combining a CNN backbone for spatial feature extraction with transformer-based temporal encoder. The proposed TC-CADNet effectively captures both intra-frame details and intra-frame dependencies. Overall, this study confirms that incorporating temporal intelligence into segmentation network is a practical and effective step towards reliable real-time clinical decision support systems. Thank you for your attention.
I request the session chair to ask questions.
Okay, I have one question. How many epochs are used for your model performance predictions? What is the number of epochs you are using your model performance predictions?
Excuse me?
Yeah. When you are comparing the performance, accuracy, precision, all the performance criteria,
About
what is the
the
number of
accuracy,
epochs? Number of
100
epochs. What is the
epochs.
number of epochs? Yeah, 100
Yes.
epochs. Now my question is, if you are increased instead of 100, 500, is it deviate the accuracy?
Repeat again, please.
Number of epoch if are increases instead of 100 to 150 or 200, is it affect the performance accuracy?
No, if I arrive to the 100, when I increase the epochs, the result gave to me the same precision and the same dice. Maybe in maybe 0.921, maybe 0.9211 like this, and the increase is very slightly.
Okay,
So I
thank you.
think the 100 epochs is like ideal number for
Yeah,
my work.
okay, thank you for your nice presentation.
Thank you very much.
Thank you. How could this model be adapted to detect other gastrointestinal pathology in endoscopic video sequences?
Yeah, the model runs, as we mentioned, about 28 FPS on an RTX class. We applied this model in real time. Yeah, we applied and satisfy real-time clinical requirements for colonoscopy systems. And we applied experiments were conducted using NVIDIA GPU with standard CODA acceleration. Yeah, it's we applied about the device, not just for experiment.
Okay, so we can use this method for other types of pathologies.
I didn't test it about that. My work is focused about the colorectal and using colonoscopy videos. Of course, if you can use another devices we can succeed about to take like this result.
Okay, thank you.
Thank you very much.
Thank you. We will be now moving to the next presentation. We now invite Anthasios Korsaris to present his paper titled Themilda, an embedding model for Greek legal retriever augmented generation.
Can you hear me, everyone?
Yes, we can hear you.
Okay, let me share my screen. Can you see my slides?
Yes, we can see your slides.
Okay, first of all, I would like to thank everyone on behalf of our team at Novel Core for inviting us to present in this conference. I am Athanasios Koursaris, and I'm an AI engineer at Novel Core based in Athens, Greece, and I'm also a PhD candidate on the University of Patras. Today, we will be presenting Themilda, an embedding model for Greek legal retrieval augmented generation, or RAG, named Themilda due to the legal context after the Greek goddess of justice. Our main motivation behind this work is as follows. First of all, current state-of-the-art lexical matching methods are inefficient for legal information retrieval, since traditional information retrieval systems such as TF-IDF and BM25 rely on surface-level textual correspondence or similarity, which proves quite insufficient where semantic precision is of paramount importance. The morphological richness of the Greek language makes this even harder, since inflectional variation produces multiple realizations of identical legal concepts due to inflection, tense, and other grammatical phenomena. Secondly, large language models, the generator component of a RAG pipeline, exhibit significant limitations in legal contexts, since most of them suffer from temporal knowledge boundaries, like missing recent legislation due to knowledge cutoff, hallucinations, and a lack of verifiable sourcing. Legal practitioners require systems that can anchor outputs in actual case law and current statutory provisions. Third, methodology for fine-tuning embeddings, especially for domain adaptation, is quite shallow, since conventional contrastive fine-tuning methods rely on synthetically generated query document pairs, capturing only surface-level patterns. This neglects the hierarchical relationships, the legal cross-references, and the precedential dependencies that characterize legal domain knowledge. So, we come to our work, which has the following contribution. First of all, we developed Themilda, a specialized Greek embedding model, a transformer encoder model of the Roberta family for legal RAG applications, which is capable of capturing hierarchical legal relationships and terminological dependencies specific to Greek legal texts. Secondly, we propose a knowledge graph-based fine-tuning methodology that integrates structured legal knowledge to enhance semantic representations extracted from Greek legal corpora. And third, we present empirical evidence and numerical analysis that Themilda outperforms fine-tuned Greek embedding models in information retrieval tasks and validate its effectiveness on when it comes to KG-based fine-tuning. So, a bit of words for our KG-based fine-tuning methodology. This is a high-level overview of the algorithm used in the paper. What's happening now in the field of information retrieval is the traditional approach where synthetic questions, natural language queries, are generated from document chunks, which leads to fine-tuning with contrastive learning methods on anchor positive pairs. That means query and document pairs. That captures only the surface-level textual patterns, neglecting the fine-grained semantic details. Our proposed approach is as follows. We construct a knowledge graph from legal texts, then we extract multiple anchor types for richer contrastive learning. Now, we have several steps to do so. First of all, we segment our text in chunks of 512 tokens with a 50 token chunk overlap, which leads to a collection of chunks, a set of distinct chunks we have in our corpus, we have 3 million chunks, if I recall correctly. Secondly, we extract information to build our knowledge graph from the chunks. We use a large language model which extracts entities, relationships, and atomic facts, as well as natural language questions from each chunk, which leads to the creation of a knowledge graph. Third, we map the knowledge graph to our domain ontology, which leads to a structured metadata-enriched knowledge graph. Then we move on to sampling random anchors, atomic facts, questions, entities per chunk, and we create a diverse anchor set. Finally, we construct anchor-positive pairs in order to proceed to contrastive learning with our fine-tuning dataset. The loss function we use during fine-tuning is the multiple negative ranking loss, and the anchors are tend to be closer to true positives and distant from unrelated samples. When we say closer, we mean by means of cosine similarity. Our ontological framework is this. We can see that the document contains various chunks. A chunk has entities, and that entity, each entity has a relation with other entities. The atomic facts are concise statements that describe these relations, and there are also natural language questions that are also traditionally used for contrastive fine-tuning. Now, a bit more about the anchor types. For each chunk, the algorithm samples 3 types of anchors from the knowledge graph. First of all, we sample atomic facts, which are concise statements distilling entity relations in a descriptive manner, and they are extracted from the knowledge graph nodes that are linked to the specific chunk. MA is the sampling parameter determining the number of atomic facts sampled. Secondly, we have natural language questions, which are firmly anchored in the chunk's textual content, whose answers are contained within the chunk, marked by the parameter MQ. Third and finally, we have the entity-based sentences, which are generated using 5 entities from the chunk, capturing entity relation contexts and co-occurrence patterns. Each anchor, either atomic fact, question, or entity is paired with its source chunk C as the positive match, forming an anchor positive pair, query document pair, and it is added to the training dataset. This produces diverse yet contextually coherent expressions of semantic content, and it is a key advantage over traditional question answering approaches that capture only question document patterns. About fine-tuning and experimentation, we have benchmarked this methodology on current state-of-the-art Greek encoder models such as Greek BERT, Greek Legal Roberta, and we also use Gem Roberta, which is our in-house encoder model, to fine-tune Themida. We use, for each fine-tuning, we use per chunk 5 atomic facts, 5 questions, and 5 entities, and in order to prove the robustness of our methodology, we also trained Themida with substantially less data, sampling 3 atomic facts, 3 questions, and 3 entities from each chunk. The state-of-the-art models were fine-tuned using traditional and knowledge graph-based methodologies, and while our model, Themida, was only fine-tuned using knowledge graph-based methodologies. So, our fine-tuning corpus consists of issue of the Greek Government Gazette, Hellenic Parliament proceedings, the Greek Parl corpus, and the decision of the Council of the Greek State. The evaluation was performed on 1,500 human-crafted queries, 500 per dataset by a legal expert and a linguistic expert. Our metrics for evaluating retrieval were accuracy at K and NDCG at K at various retrieval depths, mainly 3, 5, 10, and 20. For training, we iterated over the dataset for 3 epochs using a learning rate of 5 times 10 to the power of -6, cosine scheduling for cosine similarity, 32 batch size, 8 gradient accumulation steps, the Adam W optimizer, and mixed precision of p-float 16. The KG extraction was performed by the GPT-4o mini language model. Now, when it comes to the evaluation is twofold, and the experimental design enables 2 control comparisons. Comparison number 1 is the methodology comparison, comparing KG-based versus traditional fine-tuning. The version of Themida, the first version that was trained on less data, versus the baselines of fine-tuned with traditional Q&A approach models, and it yields training sets of comparable size. This demonstrates that improvements originate from the KG methodology and not from increased data volume. The second comparison is the Themida versus the KG fine-tuned baselines, and Themida with a corpus where each chunk was sampled with 5 atomic facts, 5 questions, and 5 entities versus the state-of-the-art models Greek PET and Greek Legal Roberta is fine-tuned with, they are also fine-tuned with the same knowledge graph methodology and matching data volume. This demonstrates the advantage of GEM Roberta's superior pre-training. Now, on to our results, we can see that the KEG-based methodology is proven by the first version of Themida, with here denoted by the asterisk, which surpasses all of the traditionally fine-tuned KEG models and is quite close to the KEG-based fine-tuning methodologies, which shows the efficiency of the pre-training we performed on the GEM Roberta model, which is used for fine-tuning. And finally, we can see that at both retrieval depths here, at k equals 3 and k equals 10, we have the best results regarding Themida, which improves accuracy at 3 by 8.6 to 8.9%, and NDCG by 8.9 to 9.3% over traditional fine-tuning. And our model achieves the highest scores across all metrics. Now, a bit more detail about the findings. The KEG-based fine-tuning is consistently superior since it outperforms traditional Q&A methodologies across all 3 models and all metrics, with accuracy at 3, gaining about 9% gains, as we said before, and a similar gain at NDCG at 3. This confirms the value of structured semantic information. We have improvements that stem from methodology, not just data volume, as we saw with the first version of Themida, with fine-tuned with substantially less data. And also, our model GEM Roberta provides a stronger foundation, even when all models use KG-based fine-tuning. It maintains a 3.5 to 4.5% advantage, confirming its superior pre-training in high-quality Greek data, and it certainly outperforms traditionally fine-tuned Greek retrieval models. And we have consistent gains across all the retrieval depths, since both at accuracy at k equals 3 and equals 10, we see that the KEG enhanced embeddings improve both early precision and broader retrieval effectiveness. Now, there are some limitations to our methodology, and the evaluation was limited to Greek legal texts, and the generalizability into other domains such as healthcare and finance and language remains to be seen. And then we also use GPT-4o for KG construction, introducing dependency on commercial models and limiting reproducibility in cost-constrained scenarios. And we also missed the comparison against multilingual embedding models such as multilingual E5 and MGTE across cross-lingual retrieval benchmarks. Now, for some next steps, we intend to perform Matroska representation learning for adaptive embedding sizes across retrieval scenarios. We intend to also perform negative sampling strategies to further improve contrastive learning quality with hard negatives. And we also intend to perform evaluation of advanced RAG systems such as graph RAG and path RAG for complex legal reasoning. Finally, we intend to extend to other domains and some multilingual settings to see how it performs when multiple languages are involved. Thank you. As always, our models are publicly available at the company's repository on Hugging Face, and you could contact me in my email if you have any more questions. There is a detailed technical report on arXiv, and you could find more information there. Thank you. Any questions?
Okay, I have one question. How the semantic representation is maintained during the extraction? semantic representation is maintained during the representation of your text?
Mhm. How is semantic representation?
Yeah.
How is semantic representation? What was the question?
How the semantic representation is maintained during the extraction? Because you are using the type of semantic elements here, you are using different type of elements, semantic elements, extracting the inter entities relations, because
Yeah,
chunk can't use that entity. So how the semantic representation will maintain?
yeah, okay. That is a very good question. Well, that's a very good question. First of all, we have our raw documents, which are in TXT format. We chunk those documents using a sentence splitter based on delimiters such as paragraphs, punctuation, and so on. And these chunks are then processed by a large language model with a prompt adapted from GraphRag in order to extract entities, atomic facts, and questions. All of these elements are described thoroughly in the prompt, and the LLM returns a dictionary containing lists of these elements.
Okay, thank you for your nice presentation.
Thank you. Any other questions?
Any question for the audience? Okay, I have a brief one just to summarize. What role do knowledge graphs play in improving the semantic representation of legal documents?
Yes, that is also a very good question. The role of knowledge graphs is in diversifying the format of anchors, of queries. Until now, we used to have only natural language question. Let's say, what is the law regarding tax evasion? While atomic facts, like let's say some sentences or small paragraphs that describe relationships between entities in a text. So this descriptiveness allows us to contrastively learn more representations of questions while fine-tuning. And thus we can make larger and more complex queries.
Okay, excellent, perfect. In my case,
Thank
no
you very
more
much.
questions. Thank you.
I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICICT 2026. As a token of appreciation, we have I also thank our session chair for chairing the session, a token of appreciation to the chair on behalf of Team ICICT 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. This token of appreciation is for Professor Hector Rafael Morano Ocono and to Professor Saroja Kumar Roth. I would request you all to switch on your cameras for a quick snapshot of the virtual conference. I hope you have a great day ahead and take care. Thank you.